Welcome to our session today, AI Factories at Scale, Dell and NVIDIA Fabrics Transforming Enterprise AI Vision into Reality. I'm your host, Jim Fry, Principal Analyst at Omdia, covering networking and infrastructure. So our topic for the day today is, where are we currently with AI factories, and what are the latest emerging best practices, particularly as this becomes an increasing focus for enterprise IT organizations, and the important role that fabrics, by the way, in particular network fabrics, can and must play. Today we'll be discussing this with our expert guests, Saurabh Kapoor of Dell and Scott Steddon of NVIDIA. So Saurabh is a Director of Product Management for Compute and Networking at Dell. Saurabh, why don't you tell us a little bit about your background and the viewpoint you bring to the session today?
Thank you, Jim. It's good to be here with you and Scott and with everyone joining us today. I lead product management strategy for AI computer networking at Dell, and I spend my days turning the most ambitious AI visions into infrastructures that actually deliver. And we've seen that for years, right? AI has lived in the lab, and now it's the heart of every business, and that has changed everything, especially the networking fabric that keeps those GPU clusters fed, synchronized, and scaling without a single hiccup. What Jensen shared at GDC around, that we're the biggest infrastructure and built out in the history. Every company is becoming an AI company, and that means building for real scale. Infrastructure that's co-engineered from compute all the way to the network, and there's a realization that AI success isn't about bolting these boxes together. It's about how do we, bring all these tightly integrated stacks together so that data flows as fast as these models demand it. Open innovation from compute to networking is how we get there. And that's exactly what me and my team obsesses every day. And I'm thrilled to unpack that with you and Scott today.
Yeah, fantastic. So Scott is AI networking segment sales lead for NVIDIA. So same thing, Scott. Tell us a little bit about your role and kind of the viewpoint that you're bringing to the discussion today.
Thanks, Jim, and thanks, Saurabh, for the invitation to join you today. So I represent our networking business within NVIDIA as part of our AI factory team. NVIDIA is not really your traditional networking vendor in that we don't make Wi-Fi and routers and a lot of the components that you'll see from your traditional networking vendors. We're laser focused on AI factory. And so the networking solutions that we bring to market are really just in the service of AI, in the service of accelerating computing. AI, it's a huge opportunity. That's well understood. It's a massively distributed computing problem that requires not just a GPU, but a cluster of GPUs. And even if I'm talking about enterprise inference, it's still a very important thing how GPUs communicate with each other. Models are larger, mixture of experts and agentic workflows are complicated. GPUs need to be able to interact and share their resources to most effectively and efficiently drive the needs of AI. And the network is an absolute key component of it. So at NVIDIA, our networking team is a part of the AI factory team. And we work very, very closely with the rest of our business, as well as our partners like Dell, to bring end-to-end extreme co-design solutions to market to really focus on driving token output. Efficient, high-performant token output. And so we construct our network and focus our networking fabric solutions specifically on that goal.
Yeah, fantastic. So I'm so looking forward to those two really good viewpoints here. So why don't we start with just setting the stage. And I think it's useful to tie what we're going to talk about today into kind of the current and most recent news and developments. So a good place to start always is with one of the big movers and shakers in the industry, which is NVIDIA. So GTC just took place recently, and there was a lot of news that came out of that, statements, happenings related to that event. And I was there. I had the opportunity to be there and took away a few things. Maybe we can go around the table here and just talk about some of the things we heard there and use that as part of the context for our conversation today. I'll say from my chair, there's so much that came out there, but a couple of the things that really stuck with me was, more information, more advancement around AI factories. In this case, more details around Vera Rubin, some things that are happening with the addition of new accelerators like the Grok 3 LPUs and, for more data management efficiency around the Bluefield-4 SDX. I think, if that's from the technology perspective, perhaps. From the general adoption perspective, I was really interested to kind of hear Jensen talk about the fact that we seem to be arriving at the inflection point where we're going to shift from focusing on training and tuning towards what we already mentioned here, which is more inferencing. And along those lines, that's partly being driven by the rise in AI agents and agentic AI. And that was a big sort of one aspect, really interesting aspect of the event was the discussion around OpenClaw and NVIDIA's NemoClaw, for a safe environment to use those in and set up and, kind of make it manageable. But tokens, I mean, Scott, you already mentioned tokens. Tokenomics is a big topic there. It's all about trying to figure out how to most efficiently drive tokens. And behind all of this, to your point, Scott, you've got to have rock solid, high performing networks to make all of this work. So I'd love to hear, Saurabh and Scott, some of your takeaways from that event. Saurabh, what are some things from your view?
Movers and shakers, that was a good call out, Jim. No, but you captured the GTC spirit perfectly. Vera Rubin on the horizon, the shift from, to inference and agentic AI, tokenomics as the new currency. What landed for me was Jensen's line where he said AI infrastructure is being built everywhere, every company, every country. And that's right on cue, right? Dell celebrated the 2-year anniversary of our AI factory with NVIDIA at GTC by turning that vision into racks you can deploy today. 4,000 customers already running Dell AI factories powered by NVIDIA, delivering about 2.6 times ROI in year one. We launched the brand new Dell AI data platform with NVIDIA that automates the full data cycle, from discovery to prep to governance, vector indexing, running on our latest PowerEdge servers. We shipped the first NVIDIA GP300 desktop systems for autonomous agents that Jensen was going to sign and put his signatures on the box at the show floor. On the networking side, we extended our Sonic capabilities, the Dell Sonic solution, to support NVIDIA Spectrum X Ethernet solutions, the power switch, SN5610, the Spectrum 4 platform, SN2201. We also announced the launching of SN6000 series, the Spectrum 6 switches with co-package optics, liquid cooled capabilities. What's important to note here is that these aren't just checkboxes, right? These are massive innovations. They are the bridge from pilot to industrial scale AI innovation. And the new data orchestration alone is slashing the time from pilot to production dramatically. The SN6000 launched 1.6 terabyte liquid cooling, co-package optics, and that basically makes yesterday's networking look like a dial-up modem in a fiber world. So let's hear it from Scott. Scott, what stood out most to you from the NVIDIA side?
Yeah, the conversation around inferencing and tokenomics is certainly my key takeaway. The kind of realization that GPUs are still an absolutely key element of an AI factory. How many tokens I can produce in this massively parallel model using a single or thousands of GPUs all working together. That's important. That's absolutely important. But also, when I'm looking at the economics of that token production, there are other elements that become very important in the equation. And so, the Grok investment and licensing that we've done and the introduction of those platforms, this gives us the flexibility of design to really sit down and consider the use case, right? And so what I'm excited about to work with Dell on is working with customers on understanding their workloads and really mapping their outcome, their goals and their expected outcomes of that AI factory to the right infrastructure. Maybe it's all GPU. Maybe there's a mix of LPU. We're also seeing high demand for CPU in this environment. As part of that sort of overarching STX architecture that you mentioned before, there is a conversation around a lot of new requirements for storage, also new requirements for CPU only racks. And we introduced some things around the Vera CPU to go alongside Rubin that, for sandboxing and agentic workflows and AI coding exercises, I need a place to run the thing that I'm building, right? I might be using the AI to create a whole bunch of code, and then I'm going to ask that agentic AI to go test that code. And if that code runs on a CPU, I'm going to need a rack of CPUs to run that on. And if I'm asking an agent to go work on a bunch of problems for me and crunch on data that is traditional IT data that maybe hasn't been accelerated and ported to GPU platforms, I still need CPUs to work on. But the reality here is all of this is highly interconnected. And so we've got a lot of understandings of how to scale and build networks for AI training. Yeah, I mean, it's still a fascinating problem that evolves every single day. But we've also got all of these new scaling frontiers and ways to consider interactivity between systems. And that drives a whole bunch of networking requirements. And so, yeah, our focus is really kind of supporting all of these things that Jensen laid out. We're working really hard on what the network fabric looks like between GPUs and LPUs. We're working with Dell on a bunch of new switching platforms. He mentioned the 6000 line, the Spectrum 6 based platforms using co-packaged optics. There are a whole bunch of ways to approach the holistic AI factory to meet those AI requirements, those tokenomic, thoughtful, thinking through the tokenomics, the economics of producing those tokens to build the highest performant. And then I'm going to keep coming back to this the whole time, the most efficient system to support this. We all know power is our big crunch in most environments. And if we can make that token output more efficient, more tokens per watt, that's our first focus. And so the co-packaged optics stuff that we're doing on the networking layer is very much focused on, yes, reliability, yes, high performance, but energy efficiency. And so big focus. And so that was exciting to see. A lot of the things around digital twins and entire AI factory reference architectures, all the way down to the land and shell and the building design and how we optimize every layer of the stack for efficient, high-performant token production. It's an exciting time for sure.
Yeah, for sure. I love that. I think this is the first time I think I've from the traditional networking chair, I've really started to think about the role that networks play in the tokenomics picture, because ultimately, networks have to tie together these elements that are going to be used for driving the AI applications, and the AI workloads that consume and produce tokens. So you have to all sort of change your thinking to include tokenomics and token efficiency as part of all elements of the architecture, including the role the networks play. So why don't we take a quick step back and just make sure we also have. By the way, Scott, I love the point that you made, which is the fact that now there's all these more pieces involved in the next generation of AI factory architectures. We're adding more supporting accelerators around the GPU clusters to continue to drive greater efficiency and greater throughput. Because Jensen even said on stage, we've reached the edge of Moore's law, but we're still advancing. And the way we're advancing is that we're improving other scale factors and reducing and eliminating them as we find them with other, creative design approaches around the architecture. But why don't we take a few minutes and just kind of step back and make sure everyone understands what we mean when we talk about AI factory. So a lot of the AI factory focus, I think, has been really focused on the service providers, hyperscalers, neoclouds. But now's the time when a lot of enterprises are starting to look at this and say, I need to figure out how to be doing this as well. I will use some of it as a service, but I also need to know how to do it internally. And I think now is a really interesting time to start looking at how that pivot's taking place and how this can be made available and consumable and understandable for the enterprise community. So why don't we talk, if you would, just take a few minutes, and Scott, maybe I'll start with you and talk about how NVIDIA defines the AI factory. What all is included in the AI factory?
Well, so Jensen talked about it in his keynote at GTC, and for everybody who hasn't watched that, it is a really great primer on just the state of what AI is right now. What are models doing? How are we seeing scaling? What are some of the promising use cases? Right, it's a really great starting point. And then when you watch through Jensen's keynote, you'll see him get to the infrastructure kind of conversation, and he'll lay out AI as a 5-layer cake. energy, chips, infrastructure, models, and applications. And so if I put that in the context of an AI factory is a place that's producing tokens. It is taking in energy, it is taking in data, it is applying that to some set of infrastructure that then outputs tokens. And then we work with our ecosystem and our partners and a whole bunch of ISVs to take those tokens to produce applications, to produce business value. That could be writing code. It could be a chatbot for a customer service. It could be a massive medical research project. Whatever that output is, the underlying things are energy and data in, tokens out. Now, there are a whole lot of components that go into that. And so we look at it as from the infrastructure pieces, well, there's the space power and, the land power and shell and sort of that underlying thing. We have a strong ecosystem that we work with to develop that and design the infrastructure that these systems go into. Then we work with Dell on the computing layer, and these will take NVIDIA's chips and our CPUs, our GPUs, as well as our networking chips, our NVLink components for scale up inside the rack and inside the computer, our scale out solutions using InfiniBand and Spectrum X Ethernet on our Spectrum silicon, and then layer in a whole bunch of operation tools. Dell brings a lot to bear around visibility and operations for that environment as well. And then models, Nemotron and all of the things that we're doing internally in the model development that NVIDIA is building, but also working with our ecosystem of OpenAI and Anthropic and all of the people that are building the foundational models that then we build applications around. So, that within the AI factory, there are these, we'll call them 4 sprinters, right? We call them 4 sprinters because I like to use this analogy of an Olympic sprint race. Right, this Olympic sprint race is, the 4x100 relay race. The idea here is I'm going to take my 4 best sprinters and send them out on the track. I'm going to train, I'm going to give them all the nutrition and healthcare that they need so that on race day, hopefully all 4 sprinters run a world record time. But it doesn't matter if each of those 4 sprinters, each individually runs their best time if anybody drops the baton. Right? It's a serial race, and runner 1 has to pass the baton to runner 2, and so on and so on, and that has to be perfect. And so at NVIDIA, we have our 4 sprinters. We have our chips, we have our our GPUs and CPUs, we have our networking solutions that are closely tied to that. We have our software layer that we build, a lot of operations tools, as well as our blueprints and Nemo and all of the model types of things. And then the 4th sprinter, the most important sprinter, because if I think strategically about how I want to win that race, I'm probably going to put my best sprinter last in the hope that they can pick up any slack that the first 3 might have presented to the problem. Right. So our 4th sprinter is Dell. It's our ecosystem. It's our partners that we work with to deliver these things to users and actually stand up these things and take them from science project to production reality. And the key here analogy to the sprint race is that we all work together to make sure that these things are extreme co-designed, very efficiently and effectively working together. The applications are optimized for the GPUs are optimized for the applications, and the CPUs and now LPUs. The networking solutions are purpose-built and designed, extreme co-design with the GPUs to support those applications. And then the relationship with Dell is rock solid, where we are here from day one, from the design phase, all the way through delivering these solutions to a customer. We're hand in hand, making sure that all of these things work together, that we can deliver them effectively, and just drive time to value as quickly as possible. And so we have this notion of an AI factory that takes all those elements, but it's not the NVIDIA AI factory. It's the Dell AI factory and the rest of our ecosystem's AI factory. And so, of course, Dell has their own flavor of the AI factory. I like to say that we will make this nice little, California influenced bowl of ramen, and then we give it to Dell, and Dell will put some Texas brisket inside and make it a Dell ramen, right? We design this recipe, and then we work with our partners to make it their own. And so Dell brings a ton of value, just getting into the network fabric, what they're doing with Sonic and being able to deliver that platform to address a whole bunch of customer needs on the operations of the network fabric. this is exactly what we want. This is exactly how we enable that ecosystem. And so we're thrilled to work with Dell on these things.
Yeah, fantastic. I'll say you need a fifth runner in your relay race, by the way, and that's the data storage systems. I didn't hear that
You're
as part
right.
of your description, so I had to figure out how to create a new analogy.
Well,
Perhaps.
and yeah, you're good point. I did sort of overlook that. That is a key component, right? And
Yeah,
just a quick reminder, NVIDIA doesn't make storage, right? We're not a storage company.
but
We have
by the
these
way,
elements
Dell
of
does.
networking and compute. And then
Yeah.
that is a key thing of our ecosystem. And so we'll come to this later, but the new STX platform and what we're doing with context memory storage is leveraging our software and our Bluefield accelerators, but it's a Dell storage solution that will actually go to market with that.
Yeah. All right. So awesome. Sora, why don't we give you a chance to talk a little bit about specifically? But did I hear you right? You said you have over 4,000 deployments of Dell AI factories already to date?
And there are factories in the enterprises. Yes, yes.
Oh, fantastic. So tell us a bit about how that's taking shape and kind of what it looks like and where what components you're lining up to support the architectures that Scott was telling us about.
Yeah, no, absolutely. I mean, Scott, you defined the AI factory perfectly, like the industrial engine where data, compute, networking, and software converge to manufacture intelligence at scale. And that's what we do at Dell, and we live that every single day. For Dell, the AI factory is a fully validated NVIDIA accelerated stack, right? Powered servers with NVIDIA, Rubin GPUs and Vera CPUs and rack scale systems like the XE9812 and NVL72 for trillion parameter training in massive inference use cases. We discussed Bluefield-4 DPUs, for offloading, zero trust security, bringing the power switch, Spectrum platform capabilities, be it Spectrum X Ethernet or as Scott mentioned, the Quantum X800 InfiniBand, and with the SN6000 series coming in with the capabilities around co-package optics and 1.6 terabyte per port, with our AI optimized storage, capabilities that that Dell supercharges the AI factory. I mean, it's all coming together, and these AI factories, these systems are end-to-end deployed across hyperscalers or neo clouds, and most excitingly, these thousands of enterprise data centers, over 4,000 AI factories and counting. Everyone is a hybrid design, on-prem where sovereignty and latency rule with networking and compute engineered to bring a seamless fabric so GPUs can stay above 95% utilization even at scale. And the objective here is to bring that highly optimized AI infrastructure, combine that with our years of experience and expertise in protecting, securing, managing data, adding a layer of ecosystem, solutions that help bring flexibility, choice, ease of application development, and wrap it around with the Dell services and support capabilities, because realizing that AI skill set is still in a short supply, and the enterprise need that muscle to enable that and enable a bunch of outcomes, so that customers can take their journey easier. So we don't ship racks, we ship confidence, and measurable ROI, right? When customers arrive in with a business problem, they leave out with a production system that is already paying dividends. So that's the magic of Dell plus NVIDIA partnership. As Scott said, right, the architectural vision plus an enterprise deployment muscle with networking that is the intelligent backbone that makes it all sync together.
Yeah, fantastic. I mean, that's really in the end, you've got to install it, turn it up, make it work, and that requires bringing all these pieces together and making sure everything's there for the enterprises to get value out of it, right? So fantastic. Why don't we shift a little bit to a couple of the key design points, and of course, everyone's got their own specific needs that they'll need in design of an AI factory. There's this reference architecture, yes. But there are other kind of decision points to be made. So, in fact, why don't we just focus on the networking part of this, since that's where we want to make sure we dive in deep here. There are some choices to be made there. Certainly within the scale out, there's the choice of InfiniBand versus Ethernet. What are the options, and sort of what have you seen coming up in conversations lately with these deployments that you've been doing. Saurabh, I think I'll start with you if you don't mind.
Sure. So when you're designing AI factory, the first question is never which GPU, right? It's about, what will my workload pattern look like today and tomorrow, right? And when you look at it from a networking perspective, and it's important to start there because nothing torpedoes AI momentum faster than a fabric that can't keep up, right? So networking is extremely important, infrastructure layer in that stack. Now, InfiniBand with NVIDIA Quantum X800 still owns, the absolute lowest latency for the largest training clusters. It's a pure rocket fuel. But for the majority of the enterprises where you're looking at, inferencing, RAG, agentic workloads, and things like that, Ethernet with NVIDIA Spectrum X is winning hands down, right? You get purpose-built AI performance with full Ethernet capabilities, 800 gig shipping, 1.6 terabyte coming out soon, co-packaged optics that helps you eliminate the pluggable transceivers. You take advantage of liquid cooling capabilities that are coming up. You can scale RAS without, turning these data centers into a sauna. You take advantage of capabilities like adaptive routing with packet spray. You manage, congestion in the fabric through telemetry capabilities. And, you basically keep, these GPUs humming as expected. So, and then the magic we brought in, as Scott also mentioned, is, bringing that openness with Sonic, and, happy to double click into that. But the magic of Sonic with this, championing the largest hyperscalers on the planet, now optimized for AI, just turbocharges that. So you're basically exact same cloud native NOS with, AI optimized capabilities and hardened for AI use cases. But when we look at the compute side, right, when you're looking at the GPUs, right, the GPUs are the heart of it, right? But don't overlook the Bluefield-4 DPUs, right? They help you offload networking, storage, security, so that GPUs can 100% focus on tokens. And the latest PowerEdge XE servers with Vera CPU powered platforms, Rubin NVL72 architectures, the rack scale systems that we bring in, with 100% direct liquid cooled capabilities, the NVLink interconnected for maximum density and efficiency. It's all game changer. And from a storage perspective, the new Dell AI data platform with NVIDIA, it automates everything. Lightning fast vector indexing, exascale parallel file systems, turning raw data AI ready in hours and not weeks. And from an enterprise scale perspective, you begin small with one or two node enterprise and fencing, foundation, then you grow to full racks and then multi-rack clusters without the need for re-architecture. These modular designs that we co-engineer with NVIDIA, let you scale compute, networking, storage independently, exactly the flexibility that enterprises need when the workloads soar overnight.
Yeah, fantastic. So you hit all of the kind of key decision points, which is around which networking do I use? What combination of compute and XPUs will I be using? But we talked a little bit about the DPUs and the SDX storage layer, and then scaling. Right? You start small. Are you able to build? Scott, what else? Actually, I'll give you a chance to chime in here. Anything else that comes up regularly from a design perspective, especially around some networking decisions?
Saurabh touched on this, right? There is often a decision point. Do I go Ethernet or do I go InfiniBand? And yes, InfiniBand is our gold standard for performance. If I peel back the layers a little bit and just look at what's going on in an AI cluster, especially for training, also to a certain extent in distributed inferencing or disaggregated inferencing, but especially in training, there is so much GPU to GPU communication happening that looks like supercomputing traffic. Like things we've been seeing in HPC environments for many years. InfiniBand is the highest performing network platform for HPC workloads, for supercomputing workloads. And so it is very applicable to AI. And we do have a ton of large scale AI factories around the world, predominantly focused on training, that are using InfiniBand. It's got characteristics around being lossless, around being able to effectively manage bandwidth, to deliver things at very low latency. The way it does this is it uses the switching silicon and the network adapters, the ConnectX adapters that are on each server, to work together. So there's some telemetry happening. There's some notification process that lets the switch know when traffic flows are coming. There's this interaction that occurs between the adapter and the switch to make sure that we're able to deliver packets as quickly and most effectively. And that's very different from a traditional IT workload where the application stack and the network stack are sort of ships in the night, and the application just dumps packets onto the network without a lot of interaction, right? So that's fundamentally why InfiniBand is high performance. But the biggest challenge that we have in positioning InfiniBand in most environments is people. InfiniBand is this great technology in high performance computing and supercomputing environments, but there's not a lot of network engineers out there that are operating these platforms. Whereas a technology like Ethernet is ubiquitous, it's everywhere. There are thousands upon thousands of certified engineers that understand how to run an Ethernet network. There's a great ecosystem of developers and software and open source projects like Sonic focused on Ethernet platforms. And so the market demands Ethernet, and that's obvious. And so what we've done at NVIDIA is develop this technology we call Spectrum X Ethernet, which takes almost all of the capabilities from InfiniBand. Now, there are some specific things around in-network computing that exist in InfiniBand and NVLink, our in-rack scale-up solution, that don't exist in Ethernet. And so those solutions will always be marginally faster than Ethernet for certain use cases, but it's a very specific environment that can leverage those things. For most AI workloads, Ethernet's great, but it still needs to be end-to-end. I still need that interaction between my network adapter and the switching silicon. And so that's what we've brought to bear with Spectrum X Ethernet. And this isn't a NVIDIA only solution. You can acquire this solution from Dell using our silicon along with switches and systems that Dell is designing around that silicon, and then using the algorithms that we've developed so that those network adapters and the switches work together very closely. This gives us a model where we can build lossless, low latency network fabrics that can manage congestion and keep up with the needs of a GPU. A GPU or a set of GPUs easily flood the network, trillions of times during a training operation. We need to be able to really effectively manage congestion, make sure that if outages occur, we can route around that and keep traffic flowing, because the slowest element in an AI factory affects the entire performance of that whole AI factory. And so if I have one or two GPUs that are starved out of 1,000, well, the other 998 GPUs are going to be operating at the speed of those two slowest GPUs. So we need consistent network performance across the board to make sure that we're delivering value. And this is a key thing of tokenomics, of the economics of tokens, right? If we're having to slow down the production of tokens because the network is underperforming, we've had a huge impact on the economic viability of that whole investment just by getting something wrong on this one little layer in that stack. And so, the focus on networking solutions is really, really end-to-end. And the decision point that people usually make of if it's InfiniBand or Ethernet comes down to their network engineering staff and the people that they have. And so we're seeing great success with Dell and with our Spectrum X solutions because it's Ethernet based and because it's technology that network engineers can operate. But there's still a lot that goes into the system design and how that works. When we build an AI network, we're actually building more than one network. We'll have an east-west network, is what we call it, or often known as the backend network, that's only for GPU to GPU communication. It's closed. It's built with no oversubscription, so rail optimized topologies with full bandwidth available for every GPU. It's a complex environment, but we need to build the network with these topologies to support the demands of the GPU so that we're not impacting the economic output of those GPUs. We also build a front end or a north-south network that connects the users in and out, but it's generally a converged network that's also connecting storage. But those characteristics of needing lossless fabrics and being able to manage congestion are equally as important in a disaggregated distributed inferencing or agentic workflow, because I'm talking to storage a lot. And we need to leverage accelerators. So I mentioned the Bluefield DPU. This is a network interface card with an accelerator to offload storage functions and security functions and virtual switching functions that might generally bog down a CPU and GPU in the host onto a purpose-built network interface card to manage those things. And then that's in our reference designs, that's coupled with our Spectrum switching in a Spectrum X for front end or north-south to support the needs of storage and high-scale user traffic that also exist in an AI factory.
Yeah, all key elements to make it possible. And boy, networking has never been more critical or more cool than with the arrival of these kinds of complex, highly.
And I'll say network's always been cool. There has been a
Yeah,
narrative in the industry
course.
that networking is cool again. I'm going to say network's always been cool, but now it's really cool.
Well, why don't we take the last little bit here and focus, do a little deeper dive on how Dell is approaching this. And Dell's doing something a little different, which is the Dell team is running its own operating system, Sonic, on the Spectrum X platform. So, Sarb, can you tell us a little bit about the sort of journey and how Dell came to decide to go this route?
Absolutely. Well, I'll start with this, right? Sonic stands for Software for Open Networking in the Cloud. It's a brainchild of Microsoft, now part of open source ecosystem. It's a technology that, came into the Linux Foundation ecosystem around 2022 and now and open source software. So what Dell has been doing around Sonic is basically taking the magic, the technology that is powering the largest hyperscalers in the world, and extending it out with all the capabilities that are needed for target markets and use cases from enterprises, adding AI optimized innovation, etc. Right, and we have extended that out to NVIDIA Spectrum X, portfolio as well. But the important thing to note here is that the openness is in the DNA at both Dell and NVIDIA. And nowhere does it shine better or deliver more business impact than in networking, right? So the announcements that we had at GDC with Dell Sonic extended out to NVIDIA Spectrum X platform is something that we are adding to the fold as well. NVIDIA brings in support with the Cumulus network operating system. We add Dell Sonic on top of it. So it's basically us bringing now choice of network operating system, for the customers to take in, what meets their ecosystem requirements, best, right? And we have common customers who've gone about taking this journey, championing into the ecosystem. One such customer is Team Blue. It's a service provider in Denmark. And I was talking to Michael Lassen, the head of technology infrastructure there, and he put it perfectly with where he said with Dell Sonic on NVIDIA Spectrum X Ethernet platforms, it basically benefits them having a unified network operating system across diverse silicon architectures, right? So basically no vendor lock-in. It gives them choice and flexibility on how they want to stack it up. The biggest payoff there is the architecture of Sonic and modular design, Docker-based architecture, decoupling hardware from software. You get all the capabilities and the best practices of hyperscalers, the protocol support from BGP to RDMA, EVPN, advanced telemetry, all the way to the silicon, ease of provisioning, everything running consistently across the use cases, across the fabric from the north-south, east-west traffic, or even across the core data centers and edge ecosystem. So one unified operating system that is running across the board, giving you sub-microsecond latency capability. And other note, here is that it's a community-driven innovation, with hyperscalers and silicon vendors and ODMs, like all coming together to champion this technology. And some say it's the Linux of networking. And we wrap it up with capabilities and support. We co-engineer the Sonic stack on Spectrum with the NVIDIA engineering team. So it's a lot of innovation packed together. And we put our services capabilities, the enterprise muscle, enablement, support, deployment, enabling fabric management capabilities. Now our fabric management solution with B Networks allows management of both Cumulus and Sonic on NVIDIA Spectrum X platform. So the customer kind of really has a choice and flexibility on choosing either. So no vendor lock-in. You get the best of both the worlds. You're able to establish those ecosystems. You're able to get these AI ecosystems up and running very quickly. So that's the power of innovation, openness, open standards architecture, all coming together to champion Sonic and NVIDIA Spectrum X.
Yeah, that's great. Well, I tell you what, I think We've run out of time, so I'd like to give us all a chance to think about a few takeaways for our attendees here. I'll say great conversation, great insights into what's going on in AI factories and the role that networking is playing. I would say from my chair, this space is moving very fast. So you not only need to stay in close touch with the market as a whole, but you need technology suppliers that are actively right in the mix, and figuring out how to solve these problems and how to bring you solutions that are going to be able to be put into play. So I'd also say that while would be great to have a simple single solution for building AI infrastructure, in reality, you will need to make some design decisions along the way. So you want to make sure that the strategy you choose gives you flexibility to tune projects to your specific needs. So multi-vendor solutions and multiple vendors coming together around reference architectures is incredibly powerful. You get the leadership position of an NVIDIA and their Spectrum X platform in this case, to sort of set the ground, and then Dell bringing the rest of the story together and the pieces that you need to fill out the architecture. So it's a really great example of this collaboration in bringing this kind of combined solution to marketplace. Scott, Saurabh, why don't we start with you? Any other pieces of advice for the audience?
Well, Jim, Scott, thank you. One piece of advice, to every leader watching this, right? Don't build an AI experiment, build an AI factory, a complete open production-ready system where compute, storage, networking, are co-engineered to scale with your ambition, right? Choose partners that are already shipping at real scale, delivering measurable ROI today, giving you the flexibility to evolve without, ripping and replacing as you evolve and grow more capacity. And at Dell with NVIDIA, that's exactly what we deliver, right? Seamless integration that turns these infrastructures into a competitive advantage. Come see live us with the AI Factory with NVIDIA in action at Dell Tech World coming up in a few weeks. And, the big realization that the AI future isn't coming, it's here. And the network is what makes it fly. So let's build it together.
Okay. Scott, how about you from your chair?
Yeah, thanks, Jim. Thanks, Saurabh. Just to reiterate what Saurabh said, the network is a key component, and so from the leaders that are starting down these journeys, yeah, we don't want to just see experiments. We want to see production value. We want to help you get there. I encourage you to shift left, and by that I mean all of the people that are involved operationally in standing up your data center and your IT infrastructure. They really need to have a seat at the table from the get-go. We can't really work in this manner anymore where the application team throws something over the wall to the infrastructure team, who then goes and orders servers and then throws it over the wall to the network and the security team, and they're all scrambling to keep up. We have this mindset of extreme co-design because we know this is the best way to build high performant and efficient systems. And so I encourage our partners, our customers, to come together and work together from the get-go with the application teams and the data science teams, designing the systems, mapping workloads to requirements and infrastructure from the earliest time possible. And the network and the security team needs to be right alongside that and co-designing these solutions and making those choices in a very informed way. And with Dell, NVIDIA is here to help you do that. So we're very excited to talk to you. I hope we see each other at Dell Tech World coming up here. And thanks for the time.
Yeah, thanks. Great advice. And in fact, on that point, yeah, if you'd like to see more of more of the details around these AI factory innovations, you can go to Dell.com, or as Scott mentioned, you can go to Dell Technologies World, which is coming up May 18th to 21st. Dell will be showcasing its AI factory there. And of course, NVIDIA will be present as well. And you can hear main stage conversations between Michael Dell and NVIDIA CEO Jensen Huang to sharing, hear what they're looking at and what they're thinking about and where this goes next. So thank you, Scott. Thank you, Saurabh, for your time. And I would like to also, on their behalf and mine, thank the audience for your time and attention, both of which really are precious, and we understand that. So thank you all and have a good day.